Let's start with today's LeetCode problem. Um, we have 20 minutes to go, and the goal is to solve it um, or not, but not use more than 20 minutes. Let's see how it goes. So reading through the problem, so you are given 2D integer grid m into n and integer x. In one operation, you can add x to or subtract x from any element in the grid. A uni-value grid is where all the elements of this grids are equal. Return minimum number of operations to make the grid uni-value. If it is not possible, return -1. Okay, so problem statement is easier. Just to explain, we have a grid of integers and we have another integer x, and we need to subtract or add and make the grid uni-value. So if I add 2 here, keep 4 as it is, -2 and -4 here, that would be all 4s, right? And yeah, so if I look at this example, we can make every element equal to 4 by doing the following. So x 2 subtract x, subtract twice, and total of 4 operations were used. Let's see in this example. X is 1, so just top of my mind, I see the median value is 3, so making this 3 is gonna be 2, and this adding 1 here. So I'm getting a point. We can make everyone equal to 3. Let's see here, x is equal to 2, so it's not possible. Okay, and anything interesting in constraints? Not really. So two things that are important I see here, that is, one is it even possible to do uni value, and two, if yes, which value to choose. So these are the two important questions. A very simple approach that comes to my mind is pick the number, each number in the grid. Let's say we are taking example of this. So first we'll take 2 and try to make every other element equal to 2, right? And that should be possible. So, and that will take more time or less time, steps, sorry. So in this case we'll have like 2, 3 and 4, so that's no, 1, 2 and 3, so that will be 6 steps. Then we take second number, which is 4, and we try to do this. If it is less than 6, we take it. So in case of 4 we have 4, in case of 6 we have again 6, and so on. Yeah, but the time complexity for this is m into n squared, but it's still doable. Let's see if we can optimize, and this also answers this question, right? So if we take 2 and we are not able to make it equal to any other number, then we return false directly, so that's good. Can I optimize in some way? which value to pick. So if I sort this, grade 2, 4, 6, 8, right? And then the median is this 2 or 4 or 6. I think picking anyone is fine. If I pick 1, 2, 3, 5, picking any one of these two should be fine. Mm. But let's say I have 1, 2, 3, 9, 3, and then yeah, it's not that easy. So if let's say here it was 20, 21, 23, then picking these two should be fine. But still, let's say if it is 50 and then 46, then maybe it's not good to pick this, right? So I'm thinking in that way, like choosing a median value is not that good, to be honest. Um, but it is still better than trying all the values, because trying this is not gonna be enough for this. So anything in between will be good. Uh, 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 um, yeah, let me think. If choosing any one particular value makes more sense, or trying it all on values is good idea. Uh, 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 maybe binary search on this, but we don't know where to go based on the value that I get. Mm. Yeah, so how do I go about it? Should I do the brute force approach? Mm, I have 12 minutes. I think let me code the brute force, and then I can see if I can optimize it while coding somehow. But um, mathematically mathematically, I think taking one or two median values should be fine. But I'm not gonna take a guess around it. Is there anything else I'm missing? There can be duplicate values. MNN should be fine. Okay. Mm-mm. So is there a way to do this in a quick way? Okay. So let's do it. So var result is equal to um, what's this? So minimum number of operations. So if it's gonna be int, then let's call it int dot max value. So what we do is for I in um, let's do so r in grid dot indices, so from 0 to m, and for c in grid dot 0 dot indices, we pick the existing value as mm, as what's it called, as this value. So uh, let's say target equal to target equal to mm, grid of r comma c, and then we call this function find min. We pass in the grid r comma c, and we get value val min ops. if if we get negative value, if min ops is less than 0, return -1 in from here directly. Otherwise if otherwise we can update the result min of result comma min ops, and then at the end we can return result. This should be fine. Let's define this function min this should also take x comma min ops. Not this one, this one. So let's call it here x, and then r is int. Do we need, we don't need r and c, we don't need it. We create them here as well, so yeah, and then we repeat this thing, but we need to pass in the result here, target here. So target int. So now for each value, what we'll do is so this is current value. We'll do okay, so what we'll do is a absolute value of current minus target. So let's say it's 4, so we do 2 minus 4, or 4 minus 2, whatever it is, it will give us 2, and then not like this. Let me think. So an integer x, in one operation you can add x or subtract x from any element. Mm-hmm. Okay, so it's not like this. Okay, let me explain what my plan is, just to be clear, because this is going rounds and rounds. So my plan is to pick 2 as the value to make. Okay, and to make 2 from 4, how much I need to remove? Yeah, so that's the thing. So to make 2 from 4, I will subtract this. Um, so let's call it val remaining, right? And if remaining mod x is not equal to 0, then we know it's not possible, so return -1 from here. But if it is possible, then how many steps? So let's say this is 6 minus 2 is 4, 4 divided by 2 is 2. So um, yeah, so divided. So we need to return um, what? Remaining divided by x. Is it correct? Not return. So where steps is equal to 0, and we add 2 steps. And from here we return steps. Let me see if I'm thinking correct. So I've chosen to make it 2 in the first iteration. Um, so let's say we have done this part, we are here, so grid of RC is now 4. So 4 minus target is 2, so that's 2, so remaining is 2, and we have um, remaining mod x, which is 2. 2 mod 2 is 0, so we don't go here, and we add remaining is 2 mod divided by 2 is 1, so add 1 here. So in this case, this is 0, this is 1, this will be 4 divided by 2, which is 2, and this will be 6 divided by 2. So I think this should work. Let's see. This is brute force. This is m into n square, but ideally should work. Something error unresolved. Find min. Oh, okay, this one I need to change this. Um, okay, at least the intuition is correct and the logic is correct. Again, this won't make me pass in the interviews, but this is what it is. Let me show you this will not work because the time complexity um, is m into n square, and yeah, so that's it for today. I will think about a efficient solution. Maybe let's take 2 minutes and find it out ourselves quickly. So this guy will have 1 line or 2 line solutions. Yeah, this is difficult to understand. This one is good. Ta, ta, ta. What are they doing? Let's see. This first thing, when the grid can be made in Uni-Value, that's fine. Chase where the grid can be made Uni-Value. Yeah, this is what I wanted to know. Um, Not clear though. Is there anyone who has done a better solution? Mm, what is this lead? Median in a frequency distribution. Yeah, this is what I was looking at. To make all elements in the grid equal, all numbers in the grid must be reachable from one another. That's fine. This is only possible if every number belongs to the same sequence where the gap between consecutive values is always multiple of step size. That's fine. If it does not fit in the series, it's possible to transform. That's okay. The absolute difference with the step size of x between number and represent the number of operations. To minimize the total operations, the target must be in the median. So I had a correct intuition again, because if we instead choose like arbitrary towards, mm, let me see. So median position, median is frequency distribution. Yeah, I don't know what n is total number of elements, um, and cumulative frequency. The median is not average value. It's this thing. Okay, I need a bit of math here. But thank you so much for watching. See you in the next one.